Yes, today and this week we will deal with a topic that we have already seen, but we will get to know it a bit in a different context, namely the topics of variance, which you already know, variance of a sample, and expected value, which is something similar to the arithmetic mean of a sample. The difference now is that we are not dealing with these terms in the context of a sample, meaning that we have given data and then determine the corresponding values by summing and multiplying. No. This time it is about the fact that we have a probability distribution given and we want to assign these values according to the probability distribution. Yes, that is what we will be focusing on during this week. We will do quite a few examples, especially in the context of discrete distributions. And of course, our classic example is the roll of a die. Before we just go into depth, I wanted to do a brief overview recap. Namely, we want to look at what the individual terms mean again and how they are related. And then I want to briefly touch on a motivation similar to our corona example in the last chapter. I have brought the example of stock returns, and there is also a task that we can solve at the very end of the week. And as a recap, I have brought the following image, which attempts to summarize these concepts that we have now learned in one picture. The first thing that begins and what actually starts every random experiment is our sample space. The sample space, as you indeed remember, describes all possible outcomes that can occur when conducting a random experiment. So for example, in the case of rolling a die, it was the set of 1 to 6. Then we basically learned the concept of an event. An event was a subset of the sample space. And that is exactly the much more important concept, that we need to define probabilities. We have a second possibility, yes, exactly, so perhaps 1,000 here again. So we have events, then we can assign a probability to the event and have a probability theory. And then we learned a few things, namely Bayes' theorem, conditional probability, and the independence of events. These were all topics that we covered 2 weeks ago in the context of probability theory. Yes, next we dealt with random variables. And random variables were the concept that we wanted to explore, such as the probability that the sum of 2 dice is less than 3. For example, describe, and this was done by writing down the meaning of the random variable as a function. For example, the sum function for the sum of 2 dice, which assigns a real number to each outcome. That is, to each elementary event. And what we can do with that is we can define events from it, such as all values in omega such that the value when you substitute x is less than or equal to 3. So this is a very special event. And to this event, we can then assign a probability to the whole. And this probability, when we have x, that is the random variable x, is less than or equal to a value x. If we take the probability from that, then we see this here. And this is something we then call the F distribution. And if this function is continuous, then it is called a continuous distribution. If the function is if the function is continuous, then it is called a continuous distribution. And if this function is not continuous but has jump points, then we call that a discrete distribution. Exactly. And then we also saw that we have another relationship, especially with continuous and differentiable distributions, that we have this relationship between distribution and density, where the density is the derivative of the distribution, or in other words, the distribution is the integral over the density. And then this whole relationship also comes out in differential and integral calculus. So this is the picture Therefore, it is very important that we can somewhat categorize all these terms, as it will also be important this week. And we now want to assign an expected value and a variance to such a distribution, and later we will also assign a covariance to something like this. And I've brought another example, namely the sale of stocks, and I will briefly introduce it. We will not solve it now, but it should serve as a little motivation for you to go through 2001 this week. So let's assume we have two independent stocks. Here the word independent already comes up. You might remember from last week, we also briefly talked about independent random variables. So let's assume we have two stocks, and we label them as X and X. What these random variables describe are returns, meaning how much the gain of a stock is at a given time. And exactly what we know or what we assume is that they have the same expected gains. Okay. Exactly. So that means the expected value of the two random variables is identical, but they have different levels of risk. And the risk is described by the variance. And we assume that stock 1 has a variance of 1 and stock 2 has a variance of 2. This means, in general, that stock 1 has a significantly lower risk than stock 2. And the question now is, what percentage of stock 1 and what percentage of stock 2 should they buy exactly to keep the risk as low as possible? We will first see that the return is independent of that, but the risk can be minimized by taking a good ratio. There are actually two factors. On one hand, we naturally have the stocks with the lower risk. We should probably buy as much of that as possible, but not too much, because you know that when you buy two stocks, you diversify, and thus the risk also decreases. And between these two, there is an optimal value for how they can set up their portfolio. And that is what we want to look at. After this week's videos, we are making, well, then I hope that has motivated you a bit. And we will get started right away with the definition of the expected value. We'll see each other in the next video.